Hey, and thanks for tuning in to my talk about architecting large-scale Angular applications with Module Federation. But before we go ahead, let me first introduce myself. So my name is Juri Strumpflohner. I'm a Google developer expert in web technologies. I'm also an academic instructor and Cypress ambassador. And right now I work for NX as the director of developer experience. NX is a smart, fast, extensible build system that has been designed to work really well with monorepos, but we can see today how we can also leverage it as our main development tool for building Angular apps, specifically large-scale Angular apps. And the growth that we experienced in the last year is incredible. So we're super honored to see so many people using NX as their main tool of choice. And it also kind of confirms our mission. So we actually just crossed the 1 million mark of NPM downloads per week in January this year. In June, we crossed 2 million. And just about a couple of weeks ago, we crossed 3 million. And so we're heading very much towards 3.5 million. Who knows, maybe before the end of the year, we can still make it there. And comparing it to the Angular CLI, we actually also crossed the download numbers of the Angular CLI itself. Now, we're not really competing, but it is for us a personal milestone because we come from the Angular world as NX, and so seeing people start using it more and more really makes us happy and kind of confirms what we're doing. But today, let's actually talk about software architecture. And the software architecture term in general is a very kind of vague one and a very broad one, so it can be really hard to actually narrow it down to a couple of items. So I tried my best, and when I think about software architecture, what I try to look at specifically today mostly is the maintainability aspect, the flexibility aspect of an architecture, but also the scalability aspect. And mostly the last point here will be what we are going to cover today. And even when we look at scaling, it can be runtime scaling, so meaning the deployment aspect of scaling, where you can kind of scale up and scale down depending on how many users you have. So basically on your deployment environment, it can be things like doing edge computing, where you want to be as near as the users, as your user base, and therefore avoid large latency. Or also things like cluster setups that allow us to give all less flexibility in terms of the scaling setup. But there's also the development time scaling. So meaning you have a code base and you need to allocate teams to that code base. How does local development work? Is it efficient? Is it fast to serve up your application? Is it easy to share code? And also things like the PR lead time, which is basically a metric that measures how long does it take for when I open a PR, how long does it take to actually have that PR merged into the main development line, which is usually the main branch or master branch. And so today, again, as you can imagine, we are going more towards the development time and looking at how we can improve that. And one aspect there already is code organization. So it might not be the first thought, but it actually has quite a big impact on how you structure your app and how that scales during development time. So usually, for instance, if we take a typical Angular CLI setup, what you see there is a big monolithic structure. So you usually get an application, and then you have just different folders in that application that kind of distinguish how you actually share code and what your features are about. And so the main issue that comes up there is how do you ensure, for instance, things such as there are proper module boundaries around those features, so that features don't kind of cross-import things that they shouldn't be importing. How do you import the number of or limit the number of parts that an app can actually consume from some other part, right? All those kind of things are important. And from the scalability aspect also, potentially, how can you just test a single feature? Run tests for that, because that was the only one you actually developed on, right? So what if I told you there is a way to do all that? And if we look, for instance, at the code organization that is proposed in NX, it kind of makes things a bit more clear. Because what we have there is an app structure, which basically has an app at the very top, and then you have a bunch of libraries that you can use for structuring your architecture. And those libraries don't actually need to be reusable libraries, right? They can just be a library for that specific application that you're developing. So usually what you get is you have a very thin application that is mostly grouping and bundling the features that you want to deploy. So that is kind of your deployment container. And then you have those well-defined, I call it workspace libraries, because as mentioned, those need to not really to be kind of libraries that you would like build and publish to NPM or something, those are just for code structuring purpose at this point. Obviously, you could publish them if you wanted to, but that's not the main purpose usually. And so if you think about the team allocation perspective, this already gives us a better view of how we could allocate teams, because usually those libraries are developed or created around module boundaries, around domain areas. And so you can allocate specific teams that work on that subset of libraries or that specific library. And then you can have like more infrastructure things such as, authentication UI libraries or other types of utilities that are across all those libraries and that might be used by different teams. And those are then usually cross-cutting infrastructure teams. And so again, usually you have that app at the very top, which is your deployable, and the major part of your functionality actually lives in those libraries. And this is the structure how it looks, for instance, in NX. So you see basically you have that app folder and then you have that lib folder. And there's also, if you open up that lib folder, a clear contract among those libraries. So there's actually an index.ts file, for instance, which is kind of the barrel file which you export basically, and where you can actually basically limit what others can consume and what might remain, for instance, just within that specific library, because it's kind of just makes sense for that library internally. And so how do you use that? Well, you just link those, for instance, over the routing mechanism. So the Angular router configuration has a very easy way to like pull in lazy libraries, like lazy modules in general. And so you can directly reference the entry point index.ts file, for instance, in one of those features that lives there as a library. And so you can already see that such libraries represent a much stronger boundary than just a folder. Because like every time you build such a library, you have to export things and you have to think about like, what do I want to export? So there's that step of exporting that is kind of very specific and explicit. And this actually makes a lot of sense also if you think about architecting your Angular apps in the future with standalone components. Because there you potentially can just include standalone components wherever you want, right? So having such a contract in place might make a lot of sense and help structuring your application. And so on top of that, then we have features such as how you can like make sure those boundaries are also respected, because even though you have an index.ts file, someone could do deep imports. And so in NX specifically, for instance, we have dedicated features that allow you to assign tags to those libraries, then define some sort of configuration where you define what tags can depend on which other tags. And then there are dedicated lint rules that check those on CI. So these are important aspect again from like a scaling perspective at development time, because now you can make sure automatically on your CI system that you don't merge PRs that don't respect the established module boundaries. And the important part about all these things is the developer experience remains exactly the same. So if you look at this command, it is very, very similar to an Angular CLI command where you serve your application, right? So here we write nx serve shop, which is our app name, but it remains exactly the same experience, regardless of whether you have multiple libraries and how you structure the setup. Another problem that comes often up at this point goes towards the CI setup, because obviously as you add more libraries and add more packages, your CI might go up because that takes more time to build. And so to counterpart that, NX comes with features of just running what actually changed. So for instance, you have basically a change just in the middle basically of a library. Then NX can walk that dependency graph that it uses behind the scenes to understand, okay, the app is the one that depends on it. And so that those are the things that you're going to build or test or lint. And similarly, when something more deeper level changes like an auth library, so some more leaf nodes in our entire graph, it obviously affects more pieces, but you can see already that we take like shortcuts of what gets actually built. So we don't include all of the test runs across all of these nodes, but just what is actually necessary. And so NX does that via so-called affected commands. So here, for instance, you see NX affected test, which uses Git to understand from that PR that you created to the baseline, which is usually main, to understand like what changes have been made. It identifies the projects, and then it leverages that project graph to understand what other projects are affected by the change and runs the tests against that subset of projects. And obviously those operations then run in parallel and are kind of optimized to be as fast as possible. Now, one thing to notice here though is what about the actual build and what about the local serve times, because those are still potentially high. And the reason why they are still high is because in a normal setup or in a default setup that you use with an X, the build is still happening just at the very top. So as I had mentioned before, you could have the libraries built individually, but in the default setup, you just consume them and they're just imported. And that happens via so-called path mappings in a root level tsconfig base JSON, where NX, whenever you create a lib, it just creates like a placeholder, which is similar to an npm scope, and then it points that to an actual index.ts file. And so this is a TypeScript feature, which allows you to nicely organize your code and don't have to like mess around with relative imports. But at the same time, it also means that Webpack just pulls all those in without actually pre-compiling the individual pieces. Now, that might, in large-scale applications, lead to the issue where you now have just one monolithic build at the very top, so this could still be slow. So how could we solve that? Well, the potential solution for that could be to apply what I call horizontal slicing, meaning I would create buildable libraries rather than just having those workspace libraries that are being pulled into the main application build. So meaning each of these libraries that we see here are being made buildable. Now, to create a buildable library, there is actually a command. So by passing the -- buildable, this would be set up to make basically the library use ngpackager for Angular specifically. And so then ngpackager would take care of building that single subset basically. But one thing that you might think of now is like, well, how would that, however, help to speed up build times? Because now I would need to not just build my application, but actually build all the individual pieces separately. And the key mechanism behind that is caching. Now, caching is a feature that NX comes with where it can take like your command, it takes like the input, which can be source files, it can be environment variables and other things that you specify. It computes a hash out of that and stores that locally. And so whenever you rerun the same command, it would compare against the hash that is already present. And if it is present, it would just replay the output and produce the artifacts that might potentially have been produced as a result of running the command before. So the whole idea behind that is like you don't rerun the same command if nothing changed. And that is the key there, because in a horizontal slicing mechanism, we could then run the build of the application. That would trigger the build of the libraries below it. But if we have built some of those libraries already, they wouldn't be rebuilt. So things get faster over time. Now, this is a chart which I've created a couple years ago from like where I did test run basically buildable libraries versus non-buildable libraries from a cold startup and a warm cache. And you can already see the cold startup is actually slower, which is not entirely surprising because in a cold startup when you don't have a cache, you need to build every single library first before you can actually build the application. And ngpackager turns out to be actually quite slow in doing that. Now, within NX, we have optimized that. So we forked ngpackager internally and ripped out all the pieces that we don't necessarily need for having such an incremental build setup, but it's still kind of slower. Now, obviously, if you look at the warm cache, that is way, way faster because obviously we don't run a lot of computation at that point. And one issue you might still have though, in the end, is the Webpack linking time. So even though the single pieces are built individually, when it comes to the application build, it needs to link to those individual pieces. And again, in a large scale application, you might still suffer slow startup times. So the whole solution there is like keep splitting. And one part could be vertical slicing, or that's how I basically define it. So the difference in vertical slicing is that we don't basically have like just the application, the library is built, but we split up the actual application itself. So we reduce the scope that needs to be rebuilt in the app and not just in its dependencies in the libraries basically. And so this is what it could look like. So we still have that concept of a shop app, but rather we split it up into single subpieces, which again could reflect our domain areas. And so that then allows us, again, always paired with the caching, to just build, for instance, the first part of the application domain, which could be like my account area, because that's just what I changed. And so each application here can now be built individually. And you can already see there are overlaps, right? Some libraries are shared by those, and those again would be cached. So if we build like the second application, while the overlapping libraries wouldn't be rerun, and that would be built independently, given if we still use a buildable library setup. And so how can you do that? And so from the actual So from the DX perspective, it still remains the same. We would always run nx serve shop, regardless of whether we have split up the applications within that. So that is an important point, because you don't want to have now to manually spin up like 3 different applications or even potentially more, just for the sake of like running things faster, because then you might get again slower due to the degraded DX experience. One thing to note though in this setup is when we use nx serve, it is different than the nx serve that happened before, because now we have actually 3 applications which get spin up behind the scenes automatically, and that is managed by nx. But it also means that for serving the application, we can now do cool things like just serving them statically from a cache without actually using Webpack. And so you can imagine this would now be much, much faster, because we don't run Webpack across all those applications, but we can just serve them up. And if someone else has already used that and cached the result, it would be super fast. Now, if you want to develop on an application, you could do something like passing --dev remotes and give 1 or 2 applications depending on where you're working on. And those then would be bootstrapped with Webpack. So you still get all basically the live refresh and everything that you're kind of accustomed to, but all the other applications would actually just be statically served again. And so this can be very nicely solved with a technology called module federation. So at the very, very high level, module federation is basically the ability that we pre-compile code at build time, but then dynamically load those individual pieces at runtime. And there's some Webpack specifically provides some runtime mechanism that makes this easy and achievable also, like when we run our production application. So you can imagine module federation being something where you have a shell which kind of pulls in different kind of pieces, which are called remotes, and assembles them to one single application. And not surprisingly, very often module federation is being used in the context of micro frontends, where you want to have different applications, deploy them independently, version them independently, and then just aggregate them basically at runtime. Now, we don't necessarily want to do this in this specific scenario, because what we want to do is mostly just use the technology to split up the application subparts for the fast building of those applications, local serving, but then still deploy the whole piece as in a single application. You could obviously go a step further and just use the same config to realize micro frontends. So how does it work? Well, you can generate a new module federation with this specific command. So here in particular, we are already giving it the various remotes. Now, many people though are probably in a situation where they start with an Angular application, it keeps growing, and at some point they reach a level where they're like, the local dev serve times take like 2 minutes, which is obviously not acceptable. And so then they start splitting up. And there's a way to do that as well. So you can migrate an existing application where you set up like the host, and then it generates like basically different remotes out of that. And again, what is very important, the developer experience remains the same. So we still run nx serve and the application name, and nx handles everything behind the scenes. So let me actually quickly show you what that looks like. And so here, for instance, I have an application which is called nx Megastore, which has a shop app, and it has a bunch of libraries, and we can actually really easily see that by running nx graph. And so here, if I show all applications, you can see there's the shop app, and there's like our various sub applications down here. Now, if we focus, for instance, on this one here and increase here the proximity, you can see there is the shop app. These are our remote applications, and here are our libraries below. Now, how does it look like in practice? Well, our libraries are simple entry points. So this is a library, it has an index point where it then internally has its auth module. Now, there's nothing here very surprising or exciting, but in our application, we see now our shop application, and in the actual routing mechanism, you can see we pull in the various lazy loaded pieces. And instead of pulling in here the actual libraries, we pull in something that is called a remote module. And that remote module is something that we generated before here. And if you go into the remote module, you will see here an actual routing configuration, which then pulls in the final library that lives further down the libs folder. So this is kind of structure how those things are being pulled together. If we now want to serve this, we just run, as mentioned, nx serve shop. And you can see now it would build first the checkout remote separately, which pulls in its libraries that is connected to. It builds the my account remote, and the products remote and a couple of other setups. And finally, the actual application. And so if you go then to localhost 4200, we see the application running. Here you see the products page, checkout page, my account page, and those are all separate applications. So I can actually go here and boot here 4201, and you would see this is the checkout page. So this is the subset of that remote application that is actually running behind the scenes. Now, why is this faster? Well, if I rerun here the same NX Serve Shop application, it has now all the other applications built already from the cache. So the cache is warm and you see the serve time is now super fast. Now again, imagine this is like a very simple setup where I just have a couple of applications with just one module and the component attached to it. But in a larger scale application, you might really notice the difference here if you have to build it or not. So the interesting part of this whole setup is the actual caching. Because without the caching, we would need to rebuild all those pieces every time, so it doesn't give us a huge speed benefit. Actually, it might even be slower. But it gets really interesting if you distribute the cache, because by default it's just local. So if you distribute it, it means that you benefit even from runs that your coworkers did or your CI system, right? So you can really speed up that experience there. Now we do that with NX Cloud, so that is the way how you can connect like an NX workspace to such a remote cache. You basically just run NX Connect and it will basically connect you to a new instance of an NX Cloud workspace and have you set up locally with such a remote runner and a remote cloud runner. Now NX Cloud comes with like 500 hours for free per month, no credit card, anything required. The worst thing that happens is it just stops caching remotely. So it's definitely an easy way to try it out. And if you're a company though that says like either we need more than 500, well then you can opt in to actual like the public cloud paid process, or you can actually also reach out and we can host it in your actual data center, because some companies are, for some privacy regulation reasons, cannot really use the public hosted cloud, even though it's end-to-end encrypted. So one thing that might come to your mind now is, well, I don't really have like a large scale application, and that's totally fair. A lot of the points that were mentioned today is for really large applications, and I wouldn't advise to go fully into like such a module federation setup, because even though a lot of those pieces that we have seen today are fully automated, so generators actually provide you this setup, you don't really need to know all the details, it still comes with a small overhead. But the thing is, like, you might not yet have a large application. A very important part, in my opinion, from an architectural thing is that you never should prematurely optimize your setup, but you should have a way where you can already evolve over time. So you have a flexible structure where you know already now that if tomorrow your application scales towards a point where you want to split it up, there's an easy way to achieve exactly that. So one thing I would want to bring up as well is a thing we are personally at NX very excited about, is that we just raised a round of funding together with our new partners at Nexus and A16Z. We had got a funding of around 8.6 million. And what this will allow and what this will change basically is that we can now focus fully on NX and push that forward. So definitely keep an eye out. We have already some really good features that will help not just for the monorepo scenario, but also for developing single Angular applications, single React applications, where you have a very similar setup that you have right now with Angular CLI, for instance, having the same structure set up, but you can still benefit from a lot of the architecture setup that I've mentioned today. So to recap, what we've seen today basically is that splitting things up into smaller pieces can help you actually become faster, because you can apply the whole affected commands that NX provides, but also the more fine-grained caching layer can help speed up things. Also, by now you might notice that Webpack module federation might not just be for actual developing microfrontends. It is definitely a solution for that, or a potential solution. But it can also be leveraged for other things, as we have seen today, like for splitting up your application layers. And finally, the DX part, the developer experience, is a very important part when we develop NX setups. And so we never want to introduce some sort of mechanism that degrades your developer experience, but you should still be able to use your application as normal, but then benefit from an improved performance or improved feature setup. So if this made you curious, we have actually a YouTube channel, which is on youtube.com/@nxdevtools. And so I've put up a couple of videos specifically that go in that direction. So one being how to speed up Angular serve and build times, which covers those topics that I mentioned today, but going really deep into the code level things, and like how you can take an existing Angular CLI app and then split it up into like smaller modified pieces, and how then the caching layer works there. So definitely check out that video. Also, if you have an Angular CLI workspace right now, there are 2 videos there how you can migrate from an Angular CLI setup to an NX-based setup. And also, as I've mentioned briefly before, keep an eye on our social channels, because we're currently developing on some cool feature that will allow you to have a same structure as the Angular CLI, but still benefit from the NX mechanisms that I've shown today, basically. So thank you for watching. Definitely reach out if you have questions, ping me online, and have a great day.